Should be starting soon. First we hello YouTube. Hello YouTube. Let's start this 3. And we'll move on from there. Now the question is basically the interval between two nodes is absolute value of a minus b. It is considered perfect if adjacent nodes is either 5 or 7. Like the difference. This value is 5 or this value is 7. And given a melody, say if it is perfect or not. So basically, this question. So you're given, let's say, 1, 2, 4, 8, 1, 6, that's 1, 8. Okay. Now, we just have to calculate these differences and check if any of them is not 1, if not 5 or 7, print no, that's it. So how do I do that? Let's see this. So I have a flag variable and previous whatever. Now my first number will be my previous because first ke pehle there is no other number. And for all the other numbers, I take the input. I check if my difference is not equal to 5 or it is not equal to 7. I set my flag to 7. False. And I set my previous to X. If my flag is there true, then it will print yes or a print no. You could also do, you can make a vector and do the same, but this is what struck me, so I did this, whatever feels nice to you. Any doubts here? Cool. Let's go to B. Now in B, you need to sell soda. So he purchased N machine, a machine with N shells as well as K bottles, where ith bottle has a brand BI and a cost CI. Now, you can place any number of bottles on each shelf, but all bottles on the same shelf must be of the same brand. Now he wants to calculate the maximum amount he can earn if he is for sure that all the bottles will be sold out if you put them on a shelf. So visually, let's say there are 3 shelves here. 1, 2, and 3. Now I have 5 bottles. Brand, let's say there are 4 brands. Wait, 5 here, 10. 4 brands, and let's say iska cost is 3, 2, 1, 4, then 1, 2, 2, 3, 3, 4, 4, 5, 1, 10, 2. Now, since I can put any number of bottles in a shelf and number of bottles and in the same shelf I have to have same brand, I can basically convert this, like convert these bottles into brand comma cost, right? Mapping. What am I doing? Let's say there is 1, okay. I have 1, 2, 3, 4. Now, since I have a bottle costing 3, I'll add 3 here. I'll add 2 here, I'll add 1 here, I'll add 4 here. Now there's a bottle costing 2 of brand 1. So I do plus 2 here. Bottle costing 3 of brand 2, so I do plus 3 here. plus 4 plus 5 plus 10 and plus 1. This is basically, if I'm choosing a brand, I put all the bottles, right, of the same brand in a shelf. Why would I not choose all the bottles? Doesn't make sense. So then this equals 15, this equals 5, this equals 5, this equals 9. Now I need to choose three cells, right? Because at the end I have three cells. So I'll choose the three maximum values, right? I don't want to print the brand, I just want to print the cost. So just choose these three maximum costs. How do I do this? I do this by a priority queue or a set or a multi-set, whatever you want. Priority queue is just easier implementation, so I'll just show you. Now I'll take the input brand cost. In my map, I increment the C, which is the cost. Now in my priority queue, I just push the frequency, the costs and not the brands because now the brand doesn't really matter. And while my shelves are not empty or my brands are empty. For example, let's say I have 5 shelves, but I have only 2 unique brands. I'll just put all of them together. No? So this is while my priority queue is empty or my shelves are not. I have shelves left and brands left. I just add the top element and remove. And I just do answer print. Any doubts here? Hello.
No, no.
Cool. So yeah, let's move on to C. Now C is the thing in our college standings. I saw everyone was most of the people were struggling with C. So I'll be going a bit slower and so you understand more better. But like your Anya has a beautiful string S. She wants to make it even more beautiful by performing Q operation. Now each operation is described by two integers, I and V. Means that ith character is assigned with a value V. Now Anya loves the number 11000. So after each query, she will ask you to tell her if 110 is present in a string or not. Okay. Now let's take the string. Okay. Now in this string, do you see 1100 existing? No, right? Yeah. How would you guys? Good. A very brute force way is after every query, I change this. So let's say I change this value. I make it 1. And now I search if 11000 exists in my array or not. Now the problem is n at max will be 1 if 2 if 2 if basically means 2 into 10 raised to 5. So it's just easier to write 2 if that's why I'm writing 2 if. And number of queries is also 2 if. Now what is the worst case? Let's say let's say my worst case is all of them are ones. I have 2 if ones, and at each query I'm just setting 1 to 0, and then the second query I set 1 to 1. Okay, what I'm saying is, let's say this is Q1, Q2, Q3 is once again 1 0, and Q4 is once again 1 1. So here you see that I can never have 1100 in my string. But if I search at every single query, what is happening is I'll be searching 2e5 times, because the search algorithm best case is of n plus m, and this is not like you're not going to have n plus m here. So like best case without like without updates. Like best case with updates. There are some other algorithms, but we don't go to that now. Cool. So now you will iterate 2e5 times for every query. So you're doing n into q, which becomes 4e10, and just let you know 1e8. This is not possible. Like my best case, I have to do it 1e8 because this is 3e8 for 3 seconds, but in 1 second, C++ does 1e8 operations, and for 4e8, you'll require 400 seconds, which is too much. And yeah, so now let's come to the optimized part. So now, if I am updating this number, wait, let's do this, okay? Firstly, for every index, I store what is this 4 ahead of it, okay? This is what 1100. This is what 1000. This is 0000. This is going to be 0000. And yeah, these three are just empty because I can't have a 4 string come together. Okay. Now I have this. Okay. Let's say I am changing this value to a 1. I'll change this to a 1. How many strings will get affected? How many 4 side strings will get affected? It can be like this, like this, like this, or like this, right? So this string and this string gets affected. Yes, no? Hello. Basically, my logic is like logic as in what I'm saying is if I'm changing a particular index, I'll be changing, let's say my claim is if changing I, 4 strings will be changed, right? At max. Yes, no. And those strings will be I minus 3, I minus 2, I minus 1 to I minus comma I. Like only these strings will be changed. 1, 2, 3, 4. Okay. So now what I can do is I can store these values in a map of strings, and let's say I am changing this. Okay. Let's say I am changing a value of 1100. I change it to 1000. What will happen is I'll decrease map of this string, map of 1100. I'll decrease this count, and what will happen to this count? I'll be increasing. or at the end of the day you only need this, but I'm just storing map of everything just so it's easier for me to figure out. That's it. So like I'll just show the code so you can understand, because it's a very code heavy problem, but I'll explain it step by step. Good. So now for every a of I, what I'm doing is I'm getting this substring of I comma I plus 4. I like substring of 4 size starting at I. That is C plus substring, and I'm increasing the count. Okay. Now my answer I'll come to later. For every query, I have an index, I have a value. Since these queries are one-based indexing, I subtract a index by 1. And now first you figure out, like, let's see this, okay. Let's say it was this. And I tell you to change this to 1. It's gonna be the same string, correct? So that is this. If the value at the current index is already my value, so I print whatever answer it is and I go to contain. Now if it is not, I set my value, and what I'm doing here is I'm going j to j minus 4. Wait. So yeah, j starts from index and my count is 1. At max, I'll do 4. I'll change 4 strings. That's why my count is limited to 4. And why am I doing j also? Because j has to be within 0 to whatever, right? 0 to n. So that's why I'm doing this, and I'm just doing this. And this is basically if my if I'm at a index here, I won't have a 4 size string, right? So this is this. If I don't have a 4 size string, continue. If I have, then what originally the string was, subtract it. I update my a of j to my new substring, and I add my new substring to my map. Now what my answer is basically, if my 110 ka count is greater than 0, print yes or else print no. Any doubts here? I've seen lots of people couldn't understand, couldn't solve this. Do try to solve it. It's a good implementation based problem. Actually, you don't really need this map. You just need to store the counts of this specific 1100. But I just did it with maps, so it's just easier for me to understand. That's it. Any doubts? Yes, no, no. Good. Uh, so then let's move on to D. D is basically each cell contains 0 to 1, 0 to 9. How many times 1543 would appear in all layers of the carpet when traversed clockwise? Now, what it is saying is basically, let's make this rectangle and I'll show you what it means. Okay. Now, what it means by layer is this entire thing is one layer. This entire thing is one layer, and this is one layer. Okay. Do you understand what is a layer? Hello. Yep. Yeah. So now the question is, if I make a string out of this, let's say this was one. Oh, wait, I'll take this example only. When I make a string out of this, what will happen? I'll have 5, 4, 3, 1, 5, 8, 4, 3, 6, 7, 5, 1. Okay, this is a string I get after I traverse. Now in this string, I need to figure out how many times 1543 is occurring. Now, one thing to keep in mind is here, like if I'm checking here, I will never get 1543. But there exists 1543 here, right? So one thing you do is I add the first three letters to my last. Why am I doing this? So that let's say I start from here. I can have a 4 size substring here and here. And I won't do 4 because then this I am already counting this, right? If I add once again here, a 1 here, then I'll be double counting this, which I don't want. So at the end, what I'm doing is I'll create a string and I'll do string dot substring 0 to 3. Okay, the last first 3 characters, I'm just adding it here. That's it. Okay. Any doubts? Why am I doing this and stuff? Is it clear? No? No. Cool. I feel it's clear. Now I need to figure out how to calculate 1543. I'll just brute force. I'll just iterate. Is this 1543? No. 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 I'm doing like this, and when I get 1543, I do +1. That's it. So that's the entire algorithm. Now, how do I print this? How do I get this string in the first place? That is the hard part of the question. Figuring out 1543 is similar to figuring out 1100 in the previous one. Now, how do I do this? Let's come to the code. So there is a very standard algorithm. If you want to search around, it's called print spiral traversal. If you'll see, like there's a lead code question, there's a GFG article, you can just basically what you can do is just copy paste this code word by word. Like obviously, like since it's readily available, like obviously you don't do this, but this is something which you can do. But like you don't do this in a actual contest. If you're just practicing, you can just copy paste. But I'll tell you how this algorithm works and stuff. But if you want to refer later, you can just go to this article and you can refer it, how it is working. But now, yeah, how this algorithm works is basically I'll have a start and I'll have an end here. Okay. I'll have a start and an end. What it signifies is if I'm going like this, wait, I'll talk about it. Okay. So now I have a top, bottom, left. Yeah. Huh. So I have top, I have these 4 corners. I just need to traverse like this, right? At the end of the day. Then my corner changes to this. Then my corner changes to this. Now, From this to this, I just iterate. From this to this, I iterate. From this to this, I iterate. From this to this, I iterate. Now, a very simple algorithm, a way to do this is now, let's say you know the corners, right? Now, what are my corners? 0, comma 0. I'll explain it like this. 0, comma m. Then you have n, comma m. Wait, one base and n minus 1, comma 0. These are my four corners, okay? I set C1, C2, C3, C4. Now when I'm traversing, I just add all these numbers from C1 to C2. And what I'm changing is, I'm changing the second value. So wait, I'll just write that code for you, so it's better for you to understand. Now, array L2, C1 is what? 0, comma 0. C2 is 0, comma n minus 1. C3 is n minus 1, comma n minus 1. C4 is now. Till when will I do this? Let's just while C1 of 0 less than C2 of 0, because I shouldn't just, I have these corners. Now when I have like, when my C2 is here and C1 is here, that means there is no way I can iterate. So that's it. So I do this. And now first I want to travel here to here, right? Horizontally. So what do I do? First do I make a string. Okay. Now for C1 of 1, C2 of 1, you add A of C1 of 0 and J. That's it. Now you'll be iterating like this. So what do? C2 of 0 to C2, C3 of 0. J, comma C2 of 1. And now into travel like this. From here to here. Because I'm subtracting. So you go from C3 of 1 to C4 of 1 and you subtract. And same goes, now you go from C4 to C0. This is also subtracting. C4 of 0 with J and C4 of 1. Now that's it. Now I need to change this to this, right? How will I go about doing this is C1 0 minus equals 1, C2 is C1 of 0. You just do this for all of them. C3, C3, C4, and C5. Now answer plus equals, this is count of curve. That's it. And this is also work. So this is a different way to do it and a very easy way to just understand. Does it make sense? How am I printing? Hello. Yes, no.
Uh-huh.
Yep.
Yes.
So now you just do this. You get the count. You get the count by just doing this. For every index, I just check. Huh. And the one more thing which I forgot. 0, comma 3, which I did here. I have to do this, so you get the count. And just copy this and what? Hi, some bug, but hi. Ah, this is C2 of 1 and C1 of 1. Oh, huh. You do plus for this. My bad. Wait. This goes here to plus plus. This goes here minus plus. This goes here. So minus. This value is incremental increase and decremental. Plus. And minus. Oh, okay. I'll debug this later. Abhi, live coding is always a mess. But this is the algorithm and it should work. And if you want to see, I'll make a submission and I'll share it later. Cool. Now let's move on to E. E is a very interesting problem. And it's worded a bit off and people like lot of stuff is there and you don't need to know that much. Okay. But I have this grid. Why not use this grid? Yeah. So firstly, you're given a matrix. Okay. Matrix will be 1, 1. Let's say this. 4, 4, 4, 4, 5, 5, 5, 5, 5, and 6, 6, 6. Now, the first thing we need to know is uh, Bij is basically uh, huh. So the water flows and this stage has created channels basically. So the value of this is basically this everyone's or. Okay. Does it make sense? Like that is a question. If you see this test case also, it has mentioned this is 1 or 4, this is 6 or 3, this is 5 or 5, this is 3 or 9. And that's how you do this. And you create an OR ka matrix. Now you just need to query on these OR channels. The starting part is kind of time pass. So this it's till this becomes 3, and this becomes 7. All of these become 7 because it's OR. So now 7, 7, 7, 7, 7, 7, 7, 7, 7, 7. Huh, cool. Now the other part of the question is the queries part. Now you have M requirements. You need to figure out the first country which satisfy all of them. Okay. How are the requirements mentioned? This region should have water greater than this value. So the query is basically region, sign, and amount. One very important thing to notice is since I'm doing OR, this is always going to be in increasing order. You can try it with more examples, but it's always going to be in increasing order. Like same or increasing. That's huh. So what we can do is, let's say I'm asking you, region is basically this is a region. R1, R2, R3, R4. No wait. Huh. This is a region, R5. And this is a country. I know technically notations are different, but yeah, this is a country and that is a region. Now, if I'm telling you for this region, I want amount greater than 4, you can directly see na ki I won't be considering these countries at all. Yes, no. Hello. Yeah. So I won't be considering these countries. And how will I figure out this barrier? That I do by binary searching. Since it's increasing, I'll have some values greater than x and some values less than equal to x. So I can just remove this portion off. Now in the next query, let's say I want, oh, wait. Let's say my first query is R1 greater than 2. So I remove this region. Now I only have this region. Now I tell you R2 less than 5. So I remove this region. And how I'm removing this and stuff, I'll tell you with code. So I remove this region, I've removed this region. Now let's say the queries are over. Now whatever my first value is left, that is my answer, right? So you just do that. Now come into the code. I first take the input. Since everything is one base indexing, I just took it as one base indexing. And I take the input. Whatever the previous row's value was, Since this is a of I comma j is equal to a of I j or a of I minus 1 and j. So that is what I'm doing. And I don't need to go all the way back also because this is gonna be like, if this has value, wait, if a of 2 0 has value a of 1 0 or a of 2 0 and a of 3 0, I want to get by doing a of 3 0 or a of 2 0 or a of 1 0. Since a of 2 0 already has a of 1 0, I don't need to do this one. So that is what you do. Since it's OR, it's a property of OR field. You just have it direct. So then that's why I just go one behind and not two behind, three behind, four behind. If you go two behind, three behind, four behind, you'll get TLE because you will get TLE because n into k doesn't exceed 1e5, but n square can exceed 1e5. So that's there. Now for every query, I have an input of m requirements. Initially, my entire valid region is what? My entire valid region is this entire range. So that is my valid region. Why am I doing this n plus 1 is because that is how my binary search works. But if you do it different way, you can do it in an also. Doesn't really matter. Now, for every requirement, I have a region, I have a sign, and I have an amount. If my low is this, oh wait, damn, ouch. It might, no, it will not fail. Okay, this is not really needed. Now, my binary search is doing what? I'm getting a mid value. If my sign is greater, what does that mean? If my sign is greater, so I'll have some values less than equal to amount and some values greater than amount. All of these will give me 0 if I'm comparing, and all of these will give me 1. Now, since I want to land up here, what I'll do is L equals mid plus 1. And if my amount is greater, if I'm here somewhere, what does that mean? I need to search somewhere here, right? Now, wait, this is like this. Let's say my midpoint is somewhere here. That means I can directly eliminate all these numbers and need to binary search over this portion. And that is how I do R equals mid. And else if I'm somewhere here, so I go this region. That's why I do L equals mid plus 1. Same goes for if the sign is ulta, I just do less than, but yeah. In the opposite case, the space becomes like this. And now if I'm here and if it is valid, I need to check over here. And if I'm here, I need to check over here. So that's it. If my amount is lesser, then you do L equals mid plus 1, or else you do R equals mid. Now, if my sign is greater, huh, wait, where am I? Huh. Let's say my binary search lands over here for less than and lands over here for greater than. This is my L, this is my L. Okay, this is what happens in my binary search. Now, this means I can disregard this set entirely because these are not valid, right? not valid. So since it's not valid, my low, which is initially 1, I set it to my current valid thing. And if my L is here, I can set my high to this. And what does that mean? That means that this entire range is invalid. When my high is something, that means high and high se aage everything is invalid. Now, at the end, after this entire thing, if my low is equal to high, that means there is no valid range. So you just do -1 and low equals high. When will it happen? If it is n plus 1 or it is somewhere n. And that's it. And you set low to -1 and just print low. That's it. Any doubts? Hello. Wait. E question. Ah, you're E only. Okay. TLE on test case 6. Wait. Nikhil, if you can speak out loud, it will be better. Ah, this is the TLE. Ah, this is what I said. If I have, let's say, I am guaranteed n into k is less than 1 if I, okay. But what if I have 1e5 rows and 1 column? Your code over here is going n square, which will give TLE. No, wait. Ah, no, this is correct. My bad. Me stupid. No, Nikhil, don't worry, don't worry. You're correct, you're correct. Now, what is this? You're getting a set of, okay, you're getting the requirements. Okay, no issues. Mike's not working. Good. Now, for every index and for every condition, this might be the TLA causing factor. Yeah. You're just, yeah. This part is TLA. I'll tell you why. So, why am I doing binary search is very important. Now, there are M across all queries is 1e5. Let's say I have 1e5 requirement. Let's say I have only 2 requirements, okay? And this case only, let's say I have 2 requirements. But only valid country is my last number. 2 requirements, but my answer is 1e5. So what your code will be doing is for every 0 to n and for every query. So let's say my answer is n, like n minus 1, and for every single query, my answer is n minus 1. So what will happen is n into q. This is your worst case. And you're also doing this condition, which is actually n into q into n into m basically, because m across all queries is not that, but worst case is n into q, and n into q will give TL. Any doubts? That's why I'm doing binary search so that it becomes n into log n instead of n into q. My time complexity is q into log n. So q into it is m into log n. Sum of m into log n. and sum of m is 1e5, and my log n is 1e5. So if you want to check the time complexity, you can do this. You have 1, 2, 3, 4, 5, 6, 6 zeros, which will work more than one. Now let's go to F. Oh, damn, the problem statement was changed. What changed? Ah, okay. Huh. Okay. I didn't see that, but huh, I understood it. Wait, I charge and this question is a lot of maths, a lot of observation, but in this question, what you need to do is I want to XOR the range from L to R, but I need to only count the interesting integers and not the not interesting integers. The wait, hmm. So yeah, this equation is what it means is x mod 2 raised to I not equal to k. Okay, and this is interesting. In these type of questions, when it is like interesting ka set is too big and not interesting ka set is smaller, what we do is, if it's a sum, let's say, if I want only sum instead of XOR, let's say I want sum of range L to R, only interesting. What I can do is sum of range L to R all minus sum of range L to R only not interesting. Okay, does it make sense? Like these two are equal. And for not interesting, what do I get? X mod 2 raised to I equal to k. Since this is given, it's easy to find out these numbers rather than finding interesting numbers. Correct? Huh. So to figure this out, to get this value. Now, in this question, it's not sum, it is XOR. If it was sum, it would have been easier, but huh, XOR makes it more difficult. So my equation is still the same, but I just need to calculate this XOR value. Okay. Now this part, there is a very cool property of XOR. If you didn't know, like property of XOR, if you didn't know, you could have like, and yeah, one more thing, I just clarify the constraints. L2R is 1E18, so I can't 1E18. L, let's say L equals 1, R equals this. My number of terms is too much. I can't iterate. Now, since I can't iterate, I have to get this value in log n or over 1. Okay. Now, wait, before the property of XOR, actually. A XOR in a range L to R equals prefix XOR of R minus prefix XOR of L minus 1. Okay. From this I converted to this, from this I converted to this. Okay. Now to calculate prefix XOR, like, do you know this like, not minus, it's XOR. Did you all know this? But yeah. In sum, what we do, if it was sum, we do R minus L minus 1, right? Now, why are we doing minus? Since inverse of plus, right, inverse of plus is minus. But inverse of XOR is XOR itself. So that is a property of XOR. So that's why I'm doing a XOR here. Now coming to the main thing, main approach. Like till this point, most of the like like I would like a lot of people would have guessed it out. But now how to get this in O of 1? How to get this in O of 1? I'm just doing this part, okay? I'll come to this part later. So for this, there's a very good property, prefix XOR. No, what did I say? XOR of range. Yeah. This is the thing. To find like there's already an article about this, but I'll tell you how this works. It's kind of like a pattern, so I'll just print this pattern out for you guys. And I'll show you what it is. Okay, let's just have 1 and 0. Huh. Let's iterate 1000. 100. So if you see over here, the output, at 1 it's 1, at 2 it's 3, at 3 it's 0, at 7 it's 0, at 11 it's 0, at 15 it's 0, at 19 it's 0. So what do you see? When it is mod 4 equals 3, like what is happening is, wait, I can basically club these things into groups of 4. Okay. And these groups of 4 mein, what is happening is, if it is n mod 4 is 1, like if it's the first number in my range, then what is happening is it's always 1. If you see 1, 5, 9, 13, 17, all of them are 1. That's so convenient for us. And then for 2, here it's 3, it's 7, it's 11, it's 15. So what you see is basically it is n plus 1. For 2 it's 3, For 6, it's 7. For 10, it's 11. So for any n, if it's n mod 2, you just do n plus 1. And for 3, so you know it's 0. And if it is 0, that means n mod 4 is 0, is the fourth term, is just n itself. If you see, 12 is 12, 16 is 16, 20 is 20. So that's it. This is my prefixer. And how I'm calculating it is, wait, now this is how I'm calculating, and this always works. So what I'm doing is I'm taking a prefix XOR of all the numbers up to I, and I'm printing that. So that is what prefix XOR is, and you see there's a pattern here, and that's it. You get this prefix XOR. Now, so this part is sorted. This part is done. Ah, wait, and this is also XOR. Now, how do I calculate this? It's the same thing, XOR of L to R, wrong equals prefix R wrong, my XOR prefix L minus 1 wrong. Okay, but now how do I calculate this prefix wrong is the question. For this, I wrote another code. This is the code I wrote. Let's say I have an 8 and I want a modulo 3. Let's just print this out. What is a XOR being for every number? 3, 8, 27, 0. 35, 8, 59, 0. 67, 8, 91, 0. You still see that there's something of a resemblance. Like every 4, there's a pattern repeating. Now, how do I figure out this pattern? Is my question. This pattern basically, if you see, for n mod 2, let's just highlight this. All of these are 8s. If n mod 4 is 0, 2, it's always 8. Same goes for this. If n mod 4 is 0, it's always 0. Now, how do I get these values? 5, 9, 13. So, isn't this, wait, 35 is what? Like, you can say it is directly the same number, but in terms of mathematical term, what is it? Ah, wait. Oh, damn. What I did there is, I think, a very simpler approach to this. Ah, I, huh, damn, this is very easy. Huh. So I'll just tell you this better approach only. So for 3, it's 3. For 35, it's 5. Oh, wait, but n mod, how will I know? Ah, fair. Huh. So this is like, yeah. 3, 3, 35, 35, 66, 66, 99, 99. No. 3 is basically 8 into 0 plus 3. 35 is what? 35 minus 3 by 8. It is 4. So it is 4 into 8 plus 3. That's 35. 67 is what? If you see, 8 into 8 plus 3. That's 67. And this is 12 into 8 plus 3. Now, if you see the index is 13, 9, 1, and you're doing for, let's say, for the fifth index, what you're doing is 4 into 8 plus 3. And what is 4? 4 is just 5 minus 1. This is 1 minus 1 into 8 plus 3. So you just do, your formula becomes, wait, I'll just write it down here. For, wait, not required. What was I doing? Yeah. And wait, I'll just verify this also. I'll tell you this. The power doesn't really matter. It's still gonna repeat. Like this same thing is gonna repeat. And I'll tell you what is it. So there are cases if n mod 4 equals 0. So you return 0. If n mod 4 equals 1, it's over here. All of these are basically return n minus 1 into 2 raised to I. And if n mod 4 equals 2, you return 2 raised to 1. So see here 16, 16, 16. And the last case, wait, I'll do it with 8 only, so it's easier to see for you guys. 27 is what? 27 minus 3 by 8, which is 3. 59 is what? 7. So at 7 you're doing into 7, at 3 you're doing into 3. So that's it. And n mod 4 equals 3. You return n into 2 raised to n. That's it. Okay. Now let's just verify this. Like what I did was I just simulated random case and this pattern was just there always. Like basically always. This pattern was there. And yeah. The only edge case to this was when mod is 0. Here you see there is 3 ka pattern. Then there is 4. Then the 4 ka pattern is existing, but first 3 numbers are there. So these first 3 numbers, how do I calculate and how do I calculate the rest? Basically, you just see here if my case power or case 0. If it's less than 4, you see this is power, this is 3 into 8, this is 8 into 1, and this is 0. This is power into 3, and this is 0. That's it. And then you remove minus 3, and now you're left with this, right? Now, same pattern is existing. If it is 1, now this is basically 1. If it is 1, you do, wait, if it is 0, which is here, you do 0. If it is 1, it is 4 into 8, which is 1 plus 3 into 4 into 8. This is true. And if it is 2, you get n plus 4, which is if it is 6, so you do 7 into 8, which is 56. That's it. And the else case, I printed out this thing. Now this is from an n, like the number of terms. But I don't know a number, like this is my prefix wrong. Okay. But this I am getting it as prefix nth. Wrong. This I can do in O of 1. Wait, I'll type it in. Prefix nth. Wrong. I can do in O of 1. Now, how do I get from this to this and from this to this? Is where math comes in. Lots of print lines to debug. Just, yeah. Now, my first number, which is in the range, like let's say I have L to R, I want the first wrong number. How do I get that? Let's say L modulo 2 raised to I is X. And my target is what? Target is K. So what you do is basically, if I see here, K minus whatever current mod is plus the power modulo mod. And what am I doing is let's say X is 4 and I want 2 and my power is 8. So I'll need to go 4 to 8, then 0 to 2, right? It is same as doing 2 minus 4 plus 8 modulo 8. Like this is modular arithmetic. Basics of it, if you want to read about it, you can go to CP algorithms, modular arithmetic. You can just read this article in GFG, CP algorithms. And yeah, so this is how I get my first number. My last number, I reverse these two because I'm subtracting, but it doesn't really matter. So, yeah, and yeah, if my k is 0, I make it power. And how am I getting n1 and n2 is the question. N1, how do I get this? Is basically last minus k. Now, my first number will always be k in my series. Second number will be k plus 8. Third will be k plus 16, and so on. And now I get a last number. Now, to get the number of terms in this range, what do I do? Last minus k divided by 8 plus 1 because I also need to include this number. And here I'm not doing plus 1, so you just do this. And then you give it to prefix wrong and you just XOR all of them, you get the answer. That's it. Any doubts? Like this is very math heavy, like observation heavy, but yeah, took a lot of time to implement. If you know this property of XOR, it was like pretty evident. And if you see my time taken, um, I took a lot of time because I didn't figure this case out. That's it. If I would have figured this case out, it would have been very easier. And you can I think you can optimize this a lot, but this what stuck me and I just did it. Good. So I guess we can say bye to stream. Like, share, subscribe, join Discord, join WhatsApp community. That's it. See you next time.